I would like to give you a brief introduction on the software that we will use in this course. And you can see here the sort of classes for me this semester. You will have a D2L website with your own account and all the classes you register to. Let's go to this one here. In here, I have a link to the software and accounts that I would like to cover right now. You could also get to this content by going into the course organization, look at important resources, software and accounts, and that will link to the same setup. I will convert this here to full screen view, so you can just see how this would look like on a Windows desktop. There are a few things we should take care of. You should have Arduino IDE. So let's take a look what it requires to install this. Give me 1 second here. So I signed into my university account. This is linking to a file I created with all the installation instruction. If it looks like this, you can just click up here on this view, and then you just see the actual formatted text. In this class, we will often create files like these, and you can see it's pretty simple. It's a text file, and if it has a title, you put a hashtag in front. 2 of them are a subtitle. With these dashes, you make a list, and this is how it's going to look like. So let's take a look. What do we need to do in order to install Arduino IDE? So it says here, this is instructions for Windows, Mac, Ubuntu, Chromebook. Either of those you should have. So let's assume we have Windows because that's the computer I'm using right now. We go in the software download section. And we have here the standard cookie thingy. And here is the Windows download version. Do not install nightly builds because they might have bugs that are not quite finished. But this is the latest release version. Download this. Take a little bit of time until it shows up in our downloads folder. Now we can check here, downloads. This has been downloaded. We can also check the actual downloads folder on the computer. Click on this file and install it. And it will ask for all these things. 3, install only for me. 4th, that's what is going to happen. It's just going to install it in that folder. So it completed the installation process. We can actually run it and check how it's going to look like. Right, so that's the application IDE, integrated development environment, and this is like a program we're working on. Let me open something new, like make a new sketch. All right, that would be a brand new a program that you could do with this development environment. It's typical for Arduino programming. You have a setup section and you have a loop section. The loop section is continuously being run. That's where your main program is. This is where you set up your hardware. To make sure this is all working, you can actually select the board that we're going to work on. This should populate when you install it the first time. It downloads all the boards from a website. And the one we're using is the Uno. And this Arduino Uno. Right now it says no ports are discovered because I didn't plug anything into the computer. Otherwise it would recognize the USB port that the microcontroller is attached to. So we have Arduino Uno, that's okay. Maybe we want another program. We can, for example, check here some basics. See something digital. Link without delay. Maybe that's an example program that you could download. And it has some text and other stuff. This button up here will compile the program. Right? And it already says it's already finished because it's a really short program, and this button will upload it. And since I don't have it connected, we can't check. So the goal is to have this program running, to be able to select Arduino Uno, and then you're set. So let's finish this. Let's get out of it. Downloaded the code. Hold on with these sections. All right, so we finished Arduino IDE installation. Now, not all of you will have the hardware with all the sensors and motors at all the time. It's usually one set per team, but you can simulate these things. So for that purpose, we need to create an account with Vocally. So you go to this website, and where Vocally is. You can either sign up or sign in. I usually use my Google account for this. And that already recognized me. And I'm logged in. We have Arduino Uno. These are different microcontrollers. That's from Raspberry Foundation. That's ESP is a Chinese company. STM is ST Microelectronics. And Arduino is one of the older type microcontrollers. This is from examples. Let's load one. Right. Left side, it has the code that they're working on. And the right side is actual hardware. You can see there's a buzzer. There is buttons, there is LEDs, and they're all connected with wires to the actual microcontroller. And they even took the effort to program a scoreboard with I think this is a logic chip that converts some of the signal to be read with this display. That's called a 7-segment display. 1, 2, 3, 4, 5, 6, 7, plus the dot. And so we can run this. That's the code that will drive it. We run it. Okay, it flashed the yellow light. Can barely see it, so I push the yellow light. That's okay. It flashed the yellow light. And which one? Oh, I didn't. I missed it. Yellow. Let's flash the yellow again. Oh, okay. That was the right one. So it's yellow, yellow, blue. Yellow, yellow, blue. The fourth, right? And yellow, whatever. I forgot. To make a mistake. And then it will tell me game over, your score is 3. So that is a platform where you can simulate all your hardware and the code without needing the actual physical hardware. But we definitely build projects where you need the physical hardware. That's just for you to work on code and test things if you would need a little motor or buttons or other things. So let's check this one here. We have finished Vocally. Now let's go to Excel. Excel is a spreadsheet. It's a program for tables and computing the data. It's a part of the Microsoft Office, like Word, PowerPoint, and so forth. And that works best on Windows or Mac and not so well on Linux and Chromebook. For Linux and Chromebook, we would need to connect to a simulator or to a website that provides a Windows type environment. So, but university has ability to install Office. And you can go here, you can actually sign in with a university account, your student account. And I believe there is a method here to download the actual program. Let me actually check into that. So once you're logged into the online version of the Microsoft Office suite, you can actually install it locally by going here, top right, download apps, download the desktop app. That will get you to a download page, download Windows. I already have this installed on my computer. But let's see how this looks like. Excel, the Excel application. Create a blank spreadsheet. You can do here things like, for example, let's put a 1 here. Down here we put equal to the cell above, plus 1. Now this is a formula, right? A1 plus 1 is in here, so we can copy this or as we want. And now it automatically increased all the values by adding 1 to the previous cell. You can imagine you can make more and more of those type of analysis. You can also import text files that have data in it and do things with it. The one thing that's important on this application is that you have a local version where you can add the analysis toolpack. The analysis tool pack is used in our class for statistics, right? Calculate the average, calculate whether something's different from something else, so forth. So we do this here, right? Analysis tool packs. You can go, once it's installed, you can click the check marks. Solver might be useful in our class too, we'll see. So the analysis toolpack you need to have enabled. Once this is enabled, you should see on, go up here to data, all the way on the right side here, you see a data analysis, and we see the solver. So if these two things are missing, you will have a problem in the class. Okay, and this is the program that runs locally. Right? It's a local application, but Microsoft also has its online version where everything runs in a website. For example, here you can say Excel. Now you can see Excel is actually running inside a website, and that is not the same thing as the Excel application like this one that runs on your local computer. This runs in the cloud, and this is the one that we need that runs locally. So let's check out this. We did Arduino IDE, WalkMe, I discussed Excel. Now it's going to Onshape. Let's see what this one here is. The very first thing you do, you should run this Onshape check. So here, it opens web browser, and it tells you whether you have the features in your web browser that are needed in order to run Onshape. You can see here in the performance score, mine is very low because this is a virtual computer. It doesn't have graphics hardware built in. But no matter what, this should still work. So then the next thing is you need to make an Onshape account. It says here, you go up, you sign up for Onshape education account. They might ask you for the student ID or some kind of a form that will show that you are a student and working at a university. So when I do this, this is how this looks to me. Right? Second, I will start this first and then head over. Right? So this is the way this looks for me. Sign in. My account that I made many years ago. And I list all the projects I've been working on. And the last one I did here is for this class. We will build a solar tracker. And you can see here, these are the solar tracker. Up here, I'm going to mount solar panels, and there's some sensors here. It's a bunch of motors I have. They're attached with a blaze plate, and this can rotate. If we can do this up and down, right, and rotate it around, so forth. This is how this is going to work. The way this is made, you don't need to do this right now. You will learn this later. For example, the base plate, this one down here. There's a tab at the bottom here. There's a sketch. In CAD programs, you have a sketch where you outline all the drawings. And there's a rectangle. It has 60 millimeter width, a diameter hole of 3.2 millimeters, and some other features. So this is just like a drawing on a napkin. And going from here to the actual 3D item, you take items from your sketch and you grow them in 3 dimensions. So you can grow them on the side, you make another sketch on this side, and it can grow on this side. Or you can, instead of growing, you can also subtract. You make a hole, you select the circle that is the hole, and you remove the material, and so forth. Right? There's all the components I had. This was the plate, or some, I think, a hole I made, and so forth. And I also made things nicely round on the side. Right? And if everything's finished, this is how this actually is looking like. There's a recess here to put some parts in it. So I hope by end of class you have at least one program where you feel comfortable with to make these types of designs. You don't need to do this right now, but right now I need you to have access to a 3D modeling software. And that's by creating an account and letting them know that you're a university student. So, okay, let's check here again. Resources. Oh, okay, we are on the other page. Let's go back. Second here, here, right? Onshape. So we completed the Onshape installation. Now the next thing is Visual Studio Code. Visual Studio Code is used by almost all programmers. It's maintained by Microsoft, or Microsoft bought it and makes it available as open source to lots of people. This is download link. Similar as before, there are download links for Windows. This is for Unix, and this is for Mac. Right? And these extensions here, ARM, there are now laptops that have ARM processors. That's the same ones you have in your cell phone. And the x64 are the standard Intel processors. And I think with Mac, it all moved to Apple Silicon. That's like the M3, M4, and 5 processors. And with Linux environment, there's a whole bunch of different. Like usually you just have a regular Intel computer, or you might have an ARM computer. So this is getting traction here. But likely you will be in this column, choosing this x64 or for Mac over here. Let's take a look. This is the download page. And this lists everything, how to install that piece of code. So once you have it, search for it, code, Visual Studio Code. This is how Visual Studio Code looks for me. It's very similar to the Arduino IDE, but it helps me to code because it allows me to chat with an AI agent here on the side, and it can directly change a program. For example, what I've been working on for this class, made a folder, and in that folder, made a program and some descriptions and so forth. So now we have a program here that we can ask AI to make modifications. You don't even need to understand what these individual commands mean. You can directly tell it what you want it to do, and it can explain to you what it actually is. So we will do this in a second. What did we do? We installed Visual Studio Code. Right, so we've gone through this step. 1, 2, 3, 4, 5. Now I want you to get access to an AI agent. You already know ChatGPT and all the other agents where you can upload or search things, but if I need something that can actually modify and edit files on your computer, you can use OpenAI Codex. That's the same thing as the ChatGPT, but if you don't want to spend any money, they have a program that gives you $100 credit. It lasts 1 year, and then you have to sign up and pay a monthly fee. So maybe the OpenAI Codex is not what you want for this class, because you might need this later in your studies while you're a student. But GitHub Copilot has similar features. You can select OpenAI or Claude or other AI agents, and you can activate a student account with them. So the first thing you will need to do is make a GitHub account, and then apply for the student extension. So my GitHub account. What the heck is GitHub? So my GitHub account looks like this: github.com, and that's my user account here. Right. So everybody can see this. I'm not signed in. This is my account. You can see all the projects I've been working on. This is a serial interface to display data. Right, and I publish this and people can download and use it. But what I need you need to sign up. Everybody can sign up with any kind of account or email address to GitHub. I highly recommend to use a professional email address. Nothing like Mr. Poo-Poo Head or so, right? So once you're signed up, you can sign in. Let's see if this is going to work. Okay. Give me 1 second here. So this is how it looks like when you're signed in. Now I have actually my profile picture up here, and there's some notifications from people that want me to make changes to the code that I made, and it's publicly available in your account or in your profile. Likely somewhere in here is where you will be applying for the student or educator account. Okay, so once you have the GitHub account and once you have this activated, you're actually now able to link it with Visual Studio Code. So now that GitHub and Visual Studio Code are linked, we can start working on projects. So for that, I made a folder. Right? This is my documents, my classes that I work on, like your classes. And within that class, I made a little blink folder because I want to blink the LEDs. And that's the current project I work on. I select this. And now you can see on the left side here, when you click on the very top, is the Blink folder, all the files that are inside. Usually when people work on a Blink program, they're primarily interested in just turning on the LED and turning it off. For example, every half second, or every second it's turned on, it's on for half a second and then turned off. So I tried to do something simpler. I said this example shows how the LED blinks, and I would like, not simple, I would like something special. So for that purpose, I made a description of what the software is supposed to do, whatever I've been thinking about in my words. So I'm telling here in the description, the LED is connected to the default LED pin. To begin with, I want the LED, light emitting diode, the lamp, to be on for 1/10 of a second and off for 9/10 of a second. That's like on, and then it stays off for a while, and then it will just continue this way. But I want this to become different and change during the time the microcontroller runs. So I still want to blink every 1 second. So this is 1 hertz, 1 blinking per second. Once per second is 1 hertz. And after the first blink, I say, we just said 1/10 on. Now I want it 2/10 on. The third time, I want it 3/10 on. The fourth time, 4/10 on. I want it on longer and longer. And then once it's on for like 9/10 of a second, I want it to become 8, 7, 6, 5, 4, 3, and get faster and faster, like so that the LED is going to be on shorter and shorter. So initially it's just a little burst, and then it gets on a long time, and then it becomes smaller again. So that's how I describe this in my term in here, in terms in here. And I also said, make the program compact and understandable for first-year students. I also said, add comments to explain each line of code. So now, since I'm logged into ChatGPT or into the chat function of Visual Studio Code, I can open here the chat window on this side, right? And I have here the description, and I can either use automatic version of the code generator, or I can select Claude or GPT. That's OpenAI, and that's from Anthropic. So Copilot, the company, that's the GitHub company that makes Copilot, has license with these guys, and you as a student can get some credits. It should be sufficient to work for this class. So now I can tell it, read the description, and convert it to specifications. Like as engineer, you describe what you do, and then you make specification. From specification, you can make functional requirements, and so forth. This is terminology we'll use later in the class. So convert it to specifications and save them in specifications.md. So let's see what it does. And this is a really simple task, so it should not take too much effort to do this. Okay, so now it made specification file. And you read it. The system shall the hardware requirements, timing requirements, behavioral. So you read through all of this and say like, okay, this looks fine. It's like, no, I want some changes. So then you add this file and make the changes. And once you're okay with the description and the specifications, you tell it, now we're ready to make the code. Now, let's make the program that meets the specifications. Okay. It read the code that's already there. Of course, it was not right because I made some modifications here. But it changed the code. It asks me whether I'm okay with all the changes, right? It said it made 2 changes. It made changes to the LED program. The red stuff is what it modified. If you don't have it yet, everything will be green because everything's new. So it made some changes to the code. And I say, I want to keep this. And while it's doing so, it also realized it has to make some modification to the specifications. See here. No, that's actually the new file that was created since last time I called it to be executed. So there's 2 new files, the specifications and the changes to the program. And I want to keep both. Right? And so now I have a program that's made in C that you don't have to know how C programming works. It really is useful if you know, because you might want to edit this yourself. But you can make a program for a microcontroller by being very clear what the specification, what it's supposed to do. Right? So now we have this program, and we need to get it onto the microcontroller. So we go back here to the Arduino IDE. Oops, Arduino. Did I type wrong here? Arduino IDE. We can open the file. Open. Documents. ENGR102B. Blink. To the Blink program here. This is exactly the same thing, right? All the commands, everything. You can ask it now to compile it. Oh, it doesn't compile because we haven't selected the board. It did not remember which we selected before, so we have to select the board. And there was the ones we were interested was the Uno. Okay. Now we can compile it. Look at that. It took less than a second to make the program. Takes very little amount of memory, one kilobyte, right? You now talk about gigabytes, like this would be a million times. At the megabyte, would be 1,000 times what this size is, and the gigabyte would be a million times bigger than the program. So it's a very small piece of code that it made. If you click this button, it will upload it, but since there is no port, right? My computer, I have no Arduino plugged in, so it will not find the USB port, and you cannot upload it, but it can still compile and check the code. So let's see where we are now in the setup. Right. Event Arduino ID, WOPV, Excel, Onshape, VS Code, and GitHub. And then at last step, we combine the both. And I showed you an example how this works. If you can get the programs installed, the accounts made, and things kind of look like I just showed you, you should be in good shape for this class. Thanks.